The last major operation that we haven't talked about yet with terms of complex numbers is that of dividing. So we've done addition, subtraction, multiplying, and now dividing. So this is going to be really related to stuff that you did with square roots. So this is going to be mostly related to what you've done with square roots. So if you remember back in the day when you and square roots were, I don't know, buddies, you might have a problem like this. Something like that. And then you'd have some set of instructions that would say something like simplify, or divide, or the ever-dreaded rationalize the denominator. Okay. And what each one of these things meant was essentially get the square root out of the bottom. By whatever means necessary, really. Out of the bottom. So don't really care what happened, except at the end of the day, we better not have any more stupid square roots in the bottom of this stupid equation. Alright? And the way we did this, you may or may not remember. So down here we had 2 plus the square root of 7. What we do is we multiply the top and the bottom by 2 minus the square root of 7. And this thing right here, essentially what we did is we took what we had over here that was a plus sign, and we changed this over here to a minus sign. So we changed the sign in front of the square root. And whenever we did that, this new term over here, we got what we called that was the conjugate. Okay? And it's important to know that word because we're actually going to use it here when we talk about dividing complex numbers. So what we had now was essentially, we had 2 things that we had to FOIL. So we'll do that for funsies, just make sure we remember how. So we've got, let's worry about the top first. We had first, 3 times 2 is 6. Outer, 3 times negative square root of 7, so minus 3 root 7. Inner, root 5 times 2, so 2 root 5. Last, minus square root of 35, right, because root 5 times root 7, root 5 times root 7 is the same thing as root 35. Remember? Maybe? Because we did this. Does that make it better? Alright. If not, let me know. We'll make it better. Alright. So we did the top, now we'll do the bottom. First, 2 times 2, 4. Outer, minus 2 root 7. Inner, plus 2 root 7. And then last was negative square root of 7 times 7. Square root of 49. Okay. So then we got nothing on the top that did anything exciting. Blah, 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 blah. Very disappointing. But look what happened here on the bottom. Got 4. Then we had minus 2 root 7 plus 2 root 7. So essentially, those canceled out. And the reason that they canceled out is because way back here, when we saw we had a plus 7 here, we made it a minus root 7 there. And honestly, that made everything wonderful. So we got rid of that. Minus square root of 49 would be minus 7. So we got something along the lines of this, which we could simplify more if we felt like it, but we don't. But the whole point was, now there is no square root on the bottom. And this makes us inordinately happy. All right. So if you remember doing that, great. If you don't, go figure it out or email me and say, I'm stuck, and I can help you out. But otherwise, if this was just piece of cake to you, that's fantastic news, because guess what? It's pretty much the exact same thing we're going to do with complex numbers. So let's pretend now that this was 3 plus 5i divided by 2 plus 7i. All right, and I'm going to leave that here just for a second. Barely see it. Okay. As you might suspect, in order to divide this, Really what we're trying to do is we're trying to get the I out of the bottom. And the way that we do that is we multiply by a version of the conjugate, a specialized version, where we're going to change the sign in front of the I term. And what we're going to call that is, you ready for it? We're going to call that the complex conjugate. So rather than being just the conjugate, it is now the complex conjugate. And it's wonderfully exciting. Complex conjugate. Right. So now what happens? Pretty much the same thing. I'm going to follow the same process. We go along. 2 plus 7i, 2 minus 7i. And we're going to FOIL it. FOIL is our friend. So first, 3 times 2 is 6. Outer, 3 times negative 7i, negative 21i. Inner, 5i times 2, plus 10i. Last, 5i minus 7i. So that's 5 times negative 7 is negative 35. I times I times I is I squared. I times I is I squared. All this over. FOIL the bottom. First, 2 times 2 is 4. Outer, 2 times negative 7i, negative 14i. Inner, 7i times 2, plus 14i. Last, plus 7i times negative 7i. So plus 7 times negative 7 is negative 49. I times I is I squared. All right. Now, we've got a lot more work to do, actually. That's the way that complex numbers work. This is why you need to be really, really careful, because this is taking about twice as many steps as it did when we just had square roots or if we just had x's or whatever. So you've got like twice as many opportunities to do something goofy. So you really, really want to be careful. Pace yourself. Don't do this when you're tired, because it's just not going to work. All right. So let's start simplifying the top. We've got 6, then minus 21i plus 10i. So minus 21 plus 10, negative 11i. Then minus 35, and I squared, that's my dog, I squared is equal to negative 1. I'm not sure if you can hear that or not. My dog's making a funny noise. All right. Then on the bottom, I've got 4. Then I've got negative 14i plus 14i. So what's happened now? That's right. The i's have canceled out. Say, but I've still got an I on the bottom. Well, only kind of. I've got negative 49i squared, but I squared is equal to negative 1. So I've got 6 minus 11i plus 35 all over 4 plus 49. So 6 and 35 is 41 minus 11i. And then I've got 4 plus 49 on the bottom, so that's 53. Am I done? Kinda, but not really, because I still don't have it in standard form. So, standard form. Remember, I need something in the form a plus bi, and I'm kind of close, but not quite. So what I want you to do is, again, think about something that you know how to do. So what we do know how to do is we can add fractions, right? We can add fractions like nobody's business. So say we had 1/5 plus 3/5. And hopefully you say, well, that's just 4/5. Well, how'd you get the 4? Well, I added the 1 and 3, right? Yeah, so you added the 1 and the 3, and then you got 4/5. Okay? So we're going to do pretty much this, but instead of going this way with it, we're actually going to go backwards with it. So what we've essentially got here is we've got the equivalent of 1 plus 3/5. And I want you to break that into 1/5 plus 3/5. So again, over here, I'm going to write it in blue because that's what I'm doing. We've got something We got 41 minus 11i over 53. So I want to break that up, just like I broke up 1 plus 3/5 into 1/5 and 3/5. So I want something that looks like that. Okay? So over here, when I went from 1 plus 3/5 to 1/5 plus 3/5, remember the number on the bottom didn't change, right? So over here, the number on the bottom is 53. So that number goes on the bottom. Now, as for filling the rest of this out, the first number here is the real number here, 41. Got the minus sign because I plugged that in already. And then the number over here, the imaginary number, is that number here. And I wrote the I out already, so I'd be in the right format. So to put this in standard form, I've got 41/53 minus 11/53 I. So it's not pretty, but actually this is a far more suitable answer for a respectable young person like yourself to do these kind of problems. Again, if you don't put things in standard form, it's going to be frowned upon by the mathematical community, and you know what that means, so you definitely want to do it and make it look pretty.